In this video, we'll be looking at a string of examples while expanding and condensing logarithmic expressions using the last three rules that we learned, quotient, product, and power rules for logarithmic expressions. So for this particular example, we're going to have to start with what we're seeing, what we're looking at. What I would focus on first is the fact that there is a multiplication between these two pieces. The piece being x to the fourth and y inside that cube root. To do that, I'm going to go ahead and apply the product rule, or first what I'm going to do is manipulate. So I'm going to have x to the fourth times y to the 1/3. That's an algebraic manipulation. The log expression manipulations are technically also algebraic manipulations, but I'm going to call them log manipulations. So this is just an algebraic manipulation. I can do things inside the log without having to manipulate anything in a special rule, other than the rules that we already know. The next thing I'm going to do is, again, I'm going to note that this is a multiplication. With the multiplication between these two terms, I'm going to go ahead and use the product rule. Now, some of you might be thinking that I have to use the power rule here because there's a power of 4, but remember that power rule only applies to everything on the inside being to that power. So because this power is to the power of 4 and this is to the power of 1/3, those two don't agree, which means that this entire inside is not to the power of a single thing, which means that the power rule doesn't apply here. So what I'm first going to do is I'm going to go ahead and apply the product rule and tear apart that x to the fourth on the inside. Multiplication will change to addition of another log base b of y to the 1/3. Next, I'm going to go ahead and look at the interiors of these two separate logs. I'm going to notice that this is log base b of x to the fourth, and that x is the only thing in here. It all is to the power of 4. I can bring that power of 4 down in front of that particular log. So there I'm applying that power rule. I'm going to go ahead and apply the power rule over here as well, where that 1/3 power is on everything inside this log. Everything inside that log is y. So that 1/3 power is going to pull down in front, and it's going to be log base b of just y. So this is the totally expanded expression of that particular expression. So again, keep in mind that we have to look at what's in here, and we have to know more or less the concept of the order of operations in which how these things apply. Knowing that these two powers don't agree tells me that I should be dealing with a multiplication between those two expressions first. Dealing with the multiplications, then the power rules can apply afterwards. The next example we're going to go ahead and look at is log base 5 of the square root of x divided by 25 y to the 3rd. Now, in some of these examples, you might get really effective and really comfortable with manipulating a lot of expressions all at once. I'm not going to show that in this video. What I'm going to first show is how do we deal with something that looks like this. Now notice there's a multiplication in here, there's a division in here, there's multiple different kinds of powers in here. Well, keep in mind that I'm going to do the power rule last. Just like I did in this example up here, the power rule is going to happen last because each of these individual expressions, each of these individual terms, variables, or numerical values might have their own powers. And sure, a couple of them might have the same, but we can handle that later. What we're going to handle first is the fact that it's this top piece divided by this bottom piece. I want to deal with that first because otherwise I'm going to make a mistake with this bottom stuff. So I'm going to have log base 5 of the square root of x. And again, remember, the quotient rule says that division changes to a subtraction of a second log of the bottom stuff. Now, the reason why this is so important for us to recognize is because now this square root can change to a 1/2 power, and I can pull that 1/2 power down. But I'm not going to do that all in one fell swoop. I'm going to first just change it x to the 1/2. The next piece that's important is back here. These two things are multiplied together, 25 times y cubed, and the fact that they're multiplied together tells me that they should change into an addition. However, this is subtraction of this entire log. I'm going to put that whole thing in brackets, and then I'm going to go ahead and change it to what it really is. So this is minus bracket log base 5 of 25 plus log base 5 of y to the 3rd. Why is this so important for us to do? Well, it's so important because this subtraction has to distribute to both of these pieces. You'll notice here that after I simplify this one step further, x to the 1/2 minus log base 5 of 25 minus log base 5 of y to the 3rd, that these are the two pieces that have the subtractions. Notice how those are the two pieces in the original denominator. That's something for us to focus on. Anytime we see a subtraction, it's going to go in the denominator of the original log, or vice versa. If it's in the denominator, it should have a subtraction in front of its log term. So now the last thing that I'm going to do is apply the power rule to each piece. I'm going to pull down the 1/2 for this case of x. I'm going to pull the power down to this. Now technically you can rewrite this as 25 being 5 to the power of 2. I'm going to write that just above it here. So I can pull the power of 2 down. Or, more efficiently, is I can apply that rule of simplifying logarithmic expressions. What power of 5 gives me 25? So this 2 can come down in front. Log base 5 of 5 is 1. And I can get just 2, or I can go ahead and say what power of 5 gives me 25, and the answer is 2, so minus 2. I'm going to go ahead and carry down that last subtraction sign, bring down the 3 from that power on the inside of that log as the power rule tells me to, and that is going to be my entirely simplified expression. Again, keep in mind, be very, very careful with the way that you manipulate these. There is an order in which you should do them, and it entirely depends on what you're looking at first, be it multiplication as 2 separate pieces, or being a division as 2 separate pieces, and then a multiplication within one of those pieces. So, the last examples that we're going to look at in this video are the condensing examples. When we're asked to condense any kind of logarithmic expression, we're really asked to do the exact same thing, just backwards. So the first example we're going to look at is log of 25 plus log of 4. Now remember for these examples that log of 25 and log of 4 are both logs of base 10. Notice how all of these examples that we were working with, all of the log bases end up being the same, or the log doesn't exist at all. So for us to combine these, the log bases must actually be the same. So for instance, let's just say in this problem I had a plus 2. In this case, that means I have to work with this example right here and converting it further back into a log expression. And that log expression should be a base of 10. So the question is how do I convert a 2 into log base 10? Well, let me go ahead and ask myself, log base 10 of what gives me 2? That's the question mark I need to know. Well, in this case, it's going to be 100. Because again, what power of 10 gives me 100? That power is 2. So I could convert this to this if necessary, and then again, combine all like terms appropriately. That's not in the original problem. We're going to go ahead and scrap that out, but that's something for us to make note of in case it shows up later on. So for this example, the bases are already the same. I just need to combine these based on the addition. Well, the addition tells me that the inside between these two terms must be multiplied together. So it's really just log of 25 times 4. Well, 25 times 4 is 100, and sure enough, I'm back to this example over here, you'll note. Now, because I've applied the product rule here, I can still simplify this down. It told me to condense. Well, condensing seems like, again, I should probably simplify as much as possible while I'm at it. Well, log base 10 of 100, as I said over here, was 2. So that completes that particular condensing problem. The last example for condensing is going to look like this. Keep in mind that condensing these two situations together, it requires us to utilize the quotient rule because of the subtraction between two separate logs. Again, ignore the addition that's on the inside of a log. The addition doesn't affect how the particular log function will be manipulated if it's on the inside. So that subtraction there, I'm going to go ahead and change it to a division appropriately. So because the log bases are the same, it's going to be log of, this is the positive log, this is the positive log, so this is the stuff that's on top. 7x plus 6, all divided by, this is the stuff that's got the subtraction log with it, so it's going to be on the bottom. And that right there is going to be our simplified expression. We could go one step further to simplify the inside. It didn't ask us to do so, but in case I did ask, it'd be 7 plus 6 over x. And again, that's because I distribute that division of x to both terms. That's the basic simplification, not the logarithmic simplification. If it just asked us to condense the log, we would go ahead and stop there.